Good. So now that we've reminded ourselves about some of these basic properties about the probabilities, let's get into the actual inferences. That's the main part in the tutorial here. So inference is often something we think about in terms of the classical type of inference, but there are other ways of doing so too. So imagine that you have some observation or you have some data X and you have some kind of model about how they might have come about. So you assume that this data X was generated from this model, so there's a certain probability that the data was generated given some properties about the world. So these are hidden properties that you don't actually know anything about. And you might want to estimate what those hidden properties are that actually gave rise to the data. And these hidden properties, so here I've used the term theta, is something that you can then try to find. And one way to do it is to use what's called the maximum likelihood principle, where you take the likelihood of the properties over here. So you take the probability of X given theta. But of course, right now, you've already measured your X, so that's undisputable at this point here. The data is already given, but you can vary the parameter that gave rise to it then. And you can do that in a way so that they try to maximize this term in order to find the theta value that gives you this largest possible value. So this is referred to as the maximum likelihood type of principle. And I'm sure you've used that many times, whether you've been aware of it or not. So let's take a simple example. Let's say you're measuring the bolt activity from a brain area when doing fMRI. You might find that the activity is normal distributed. That's typically the case. And you might have different trials here, 1 through 5, and you're measuring from 2 different brain areas then. And given then this activity, you might want to know something about the parameters that gave rise to it. So if we believe that these are normal distributed, then of course we can summarize it based on just the mu and the sigma. So we can try to find those by then using some inferences of the maximum likelihood type of principle. So the likelihood of each trial happening, so the probability here of X given your mu and your sigma. If each trial is independent, then we can just multiply those likelihoods together to give the full likelihood of having this specific data set given an unknown mu and sigma. And of course, as we know from statistics, the values that actually maximize this function is the averaging over the data that gives us the best estimate of mu, the best unbiased estimate of mu. And then there's the sample variance, where you take the deviance, square deviance from the mean, and that gives you then the best unbiased estimate of your sigma squared instead. So you've done that before, and you know how it works, of course. But we're going to look at it a little bit more in the exercises. You'll get to think a little bit more about what likelihood really means for doing inferences, and do a little bit of a grid search to try and find some of these values of mu and sigma that has the highest likelihood.